Hey guys, here's a quick overview of centroids and the stuff we'll be talking about in class. Centroid is an object's center of gravity or the center of mass. It's the thing that the object will rotate around if it's tossed or if it's thrown in a circle, sort of like the bowling pin that we'll show in class. Centroids are labeled on graphics with this little symbol that you see right here. So whenever I ask you to mark the centroid on an object, you'll mark it with a circle, plus through it, and shade the two opposite sides. As I mentioned before, centroid is the point of applied force caused by acceleration due to gravity, state of equilibrium, balance along the centroid. What's that mean? It basically says if you're holding it up at the centroid, as you are in this particular situation right here, then it will balance, it will be in equilibrium. The torque on this side equals the torque on the right side. Now, if I put my finger over here, which is obviously not located near the centroid, this thing will not be in equilibrium. You'll have more torque over here, less torque over here, cause the object to rotate as such. So why is this important? Because we're going to start looking at different materials that we use, and when we talk about these materials, we're going to simplify it. We're going to talk about these theoretical calculations where we say things occur at the centroid location. Obviously, when you get into the real world, it gets a little bit more complicated than that, but it helps us for our basic understanding. When we talk about centroids, we'll often talk also about the cross-sectional view of a three-dimensional object. So this is a picture of an I-beam. This looks like a steel one. They also make them out of wood now in houses. You might even see some in your house if you climb up in the attic or down into the basement. But if we're talking about the cross-sectional view of this I-beam, it's like if we cut it off right here and you actually see the eye. This eye right here would represent the cross-sectional view. So when we show shapes like this, the triangle or the square or the circle, think of those as cross-sectional views. And the easiest of these to address is the symmetrical objects. These are the ones we talked about in class today, like a piece of paper. These fall on the line of symmetry. Line of symmetry is the point where you can fold it along that line and it will have identical shapes on either side of that line. Some things have one line of symmetry, like this triangle, and some things have two, like the square or the circle, meaning you could fold it twice and find that centroid location. That's the experimental determination that we talked about today. You could fold a circle twice and find the centroid by where those two lines intersect. Now, for this triangle, we could fold it in half once. We know that the centroid is going to be located somewhere on this line. We're not exactly sure where. We'll have to use a little bit of math or a little bit more in-depth calculation to figure it out. So let's start with the simple ones, right? A nice square or a rectangle. Finding the centroid location is very easy for these. It's intuitive. We just don't know that we're doing it. We've done this ever since we were little kids. To get it, to find your x centroid location, and that's symbolized with x with a line over the top or y with a line over the top. To get your x centroid location, it's just half of your base. Y centroid location, it's half of your height. So pretty straightforward, pretty easy. It's a good place to start. The next centroid that we find would be a triangle. On a triangle, it's not quite half, right, because you're missing half of the other half of that rectangle. So it turns out that it is base divided by 3 and height divided by 3. Assuming that you start at this origin right here, which is the 90-degree angle. Obviously, you don't want to start here or here because your centroid should be located closest to where most of the mass is, since you're only going to move over a third and up a third. The next one is a semicircle, as you see here. Semicircle has a line of symmetry, so you can imagine folding that in half. So the x centroid location is just half of the diameter, or the radius. To figure out how high you have to go to find that center of mass, you have to use an equation which is 4r over 3 pi. And so you can just multiply. In this case, we have a radius of 2, so 4 times 2 divided by 3 pi gives us 0.849, or about 0.8 inches that we need to go up. And we know that we need to come over 2 inches because that's half of the diameter, or otherwise known as the radius. So this is finding centroids of basic shapes. In the next video, we'll talk about how you get them with more complex shapes. So long.